Hello everyone. Last class we started the performance of ultrasonic testing system. Today we started to study the performance of ultrasonic testing system 2. Through the learning of this course, I hope to achieve the following teaching objectives. Master the influence of blind spot, resolution, and point noise level on dictation. Understand the relative sensitivity and oblique probe incident point determination. K-value and refraction angle test of oblique probe, deviation of probe main sound beam and double peak test. Resolution. Resolution refers to the ability of a system to distinguish two adjacent continuous defects. It has near field resolution, far field resolution, vertical resolution, and lateral resolution. Generally, it refers to the far field longitudinal resolution. Test method 1 of straight probe resolution is shown in figure. First, adjust the height of the two bottom of echoes of 85 mm and 91 mm on the test block to make them same height, which is approximately equal to 20 to 30% of the vertical full amplitude. And then reduce the attenuation so that the through of the two rises to the height of the original peak. At this time, the decibel or number of the attenuator changes is the resolution of the system. In NBT 470132015, the far field resolution of the straight probe is not less than 20 dB. The resolution of the oblique probe is measured as follows. Place the oblique probe on the test block and aim at the three-step holes of 550, 544, and 540, so that three reflected waves appear on the display screen. Move the probe in parallel and adjust the instrument so that the reflected waves of 550 and 544 are of equal height, and the height decibel difference between the peak and rough is delta m, which is resolution of the oblique probe. Electrical noise level E. The electrical noise level means that when the probe of the system radiates directly to the air, the sensitivity and scanning range of the flow dictator are adjusted to the maximum. Under the condition of avoiding external interference, the average amplitude of the electrical noise on the display screen is the electrical noise level value E. The smaller the E value, the better. Generally, it should be less than 8%. In addition to the main technical performance indicators mentioned above, there are some other performance requirements, such as nominal frequency, repetition frequency, frequency bandwidth, attenuator accuracy, blocking characteristics, etc. I hope that students will refer to the relevant standard after class and study on their own. The performance of the ultrasonic probe and its tests are introduced below. Relative sensitivity. The relative sensitivity is a measure that reflects the electroacoustic conversion efficiency of the probe in the form of pulse echo on a specified medium, sound path, and reflector. The specific expressions are specified differently in different standards. For example, GB T18694-2002, characterization of ultrasonic inspection probes and their sound fields for non-destructive testing, stipulates the ratio of the peak-to-peak value of the echo voltage output by the probe to the peak-to-peak value of the excitation voltage applied to the probe. Oblique probe of incidence. The incident point of the oblique probe refers to the intersection of its main sound beam's axis and the detection of surface. The distance from the incident point to the leading edge of the probe is called the probe leading edge length, L0. The point of incident and the length of the leading edge of the probe are determined to facilitate the positioning of defects and the determination of the K value of the probe. Test method is as follows. Put the oblique probe on the IIW test block as shown in position 1. When the echo of the bottom surface of the R100 cylindrical curve reaches the highest, the coincidence point of the bottom surface of the inclined wedge and the center of the test block is the incident point of the probe. At this time, the length of the leading edge of the probe is L0 equal R minus M, and the key operations are coupling. The probe is parallel to the end face, the highest echo is found, and the parallel measurement is performed 3 times. During the test, it should be noted that R on the test block should be greater than the length of the near field area in the stele, because the sound pressure on the axis in the near field area is not necessarily the highest, and the test area is large. The K value of the oblique probe and the reflection angle beta S. The K value of the oblique probe refers to the tangent value of the shear wave reflection angle in the detective workpiece. The K value of the oblique probe is usually determined by the phi 50 and phi 1.5 transverse holes on the IIW test block. When the probe is placed in the beta position, the variable that is between 35 to 60 degrees. When the probe is placed in the C position, the measurable delta is around 60 to 75 degrees. At the D position, the variable is around 75 to 80 degrees. The following takes the C position as an example to illustrate the test method of the K value. The probe is aligned with the phi 50 horizontal hole to the test block. Find the highest echo and the measure distance L from the front edge of the probe to the end face of the test block. Then K, as we can see in here. It is worth noting that the K value of the probe should also be determined outside the near field area. Probe main beam deviation and double peaks. The deviation of the actual main sound from its theoretical geometric center axis is called deviation of the main sound beam, which is usually expressed by the deviation angle. When the probe is moved in parallel, the phenomenon that the same reflector produces the 2 peaks is called double peaks, which is caused by beam birefraction. Both straight probes and oblique probes may have main sound beam deviation and double peaks. The following takes the inclined probe as an example to illustrate the determination of the main sound beam deviation. As shown in the figure, the probe is aligned with the edge of the test block. Move the probe and rotate the probe to find the highest echo of the edge. And the angle between the parallel line on the side of the probe and the normal line of the edge is the deviation of the main sound beam. As we can see, we can use the first wave to measure as shown in B. When, as we can see, use the second wave to measure as shown in C. This is because when the value of K is small, the sound path of primary wave is short, often in the near field area, and the test area is large. The probe double peak is usually measured with transverse hole test block, as shown in the figure. The probe is aligned with the horizontal hole and moves in a parallel forward and backward. When a double peaked waveform shown in figure B appears on the oscilloscope, the probe has a double peak. Probe sound beam characteristics. The sound beam characteristic of the probe refers to the diffusion of the sound beam emitted by the probe, which is usually expressed by the movement distance of the probe when the sound pressure on the axis drops by 6 dB. The probe moves a large distance, and the sound beam spreads seriously. The beam dispersion characteristics of straight probes and oblique probes are described below. First, look at the beam spread characteristic of the straight probe. Mark 1, 2, 3, 4 as you can see on the 4 symmetrical positions of the probe circumference, and then align the probe with a transverse hole with a sound path of about 2n on the test block to find the highest echo, and then move the probe in a parallel along the x-axis direction and measure the probe movement distance wx and wx when the echo of the transverse hole drops by 6 dB, as we can see as shown in the figure. Use the same method to measure the probe movement distance wy and wy in the yy direction. The sound beam diffusion characteristics of the oblique probes are different in different directions. Here we only introduce the sound beam diffusion in the left and right probes. First, the probe is placed on the test block with a thickness of 40 mm, as shown in the figure. Then, the probe is moved to find the highest emission echo of the 5-4 vertical through hole, and the center zero point of the probe is marked on the test block. Then the probe is moved around the zero point, and the movement distance wy and wy is found when the 5-4 echo decreased by 6 dB. To sum up, in this lesson, we have learned about blind spots, resolution, point noise level, relative sensitivity test, oblique probe, incident point determination, oblique probe k-value and refraction angle test, probe main beam deviation and double peak test. These are key information that we need to pay attention to before starting the ultrasonic inspection. As the saying goes, the troops and horses are not moved, the food and grass go first. Please summarize the status and role of this unit in ultrasonic inspection. Thank you. 好，结束。